Hello, this is Sergeant May with your 2022 in-service training, the Hazardous Materials block. Our duties sometimes place us near some form of hazardous material daily. We must constantly be aware of these possible dangerous materials and strive to increase our awareness in not only our environment, but also in our knowledge and understanding of the hazardous materials danger. This knowledge can assist us with observing and identifying the material and situation in the early stages, thereby reducing our chances of exposure and injury, as well as having more options and resources available for a resolution of the incident. For this hazardous materials block, your training objectives are as follows. 1. Define hazardous materials and the risks associated with them during a hazardous materials incident. 2. Describe the duties of an awareness level first responder at the scene of a hazardous materials incident. 3. List methods used to recognize the presence of a hazardous material, to include the identification of the possible material or substance based on readily available clues. 4. Demonstrate the ability to use the DOT Emergency Response Guidebook in identifying a hazardous material and appropriate first responder actions, to include notifying additional resources. And number 5, recognize hazards when responding to potential incidents involving illicit drug laboratories and chemical suicides, and how to implement appropriate protective measures. We are all sworn to protect and serve the public from various situations, including hazardous material incidents. As mentioned earlier, we often encounter environments where hazardous materials may be present. We must utilize a safe response and protocol when dealing with these dangerous materials and situations. The Occupational Safety and Health Administration, or OSHA, was created by Congress to assure safe and healthful working conditions for working men and women by setting and enforcing standards and providing training, outreach, education, and assistance. OSHA establishes regulations for employing organizations and defines responder levels. Various organizations have different definitions of hazardous materials. The following information pertains to the definitions of hazardous materials is defined by OSHA and the U.S. Department of Transportation. A hazardous substance or material is any substance to which exposure results or may result in adverse effects on the health or safety of employees. The hazard class of dangerous goods is indicated either by its class, number, or name. Placards are utilized to identify the class or division of a material. The hazard class or division number must be displayed in the lower corner of a placard and is required for both primary and subsidiary hazard classes and divisions, if applicable. The hazard class or division number and subsidiary hazard classes or division numbers must appear on the shipping document. Your Class 1 are your explosives. Division 1.1 are explosives which have a mass explosion hazard. Division 1.2 are explosives which have a projection hazard, but not a mass explosion hazard. Division 1.3 are explosives which have a fire hazard and either a minor blast hazard or minor projection hazard, or both, but not a mass explosion hazard. Division 1.4 are explosives which present no significant blast hazard. Division 1.5 are very insensitive explosives with a mass explosion hazard, and Division 1.6 are extremely insensitive articles which do not have a mass explosion hazard. Your Class 2 placards are your gases. Division 2.1 are your flammable gases. Division 2.2 are your non-flammable, non-toxic, or non-poisonous gases. And Division 2.3 are your toxic gases. Your Class 3 are your flammable liquids and combustible liquids. Your flammable liquids have a flash point below 141 degrees. Your combustible have a flash point between 141 and 200 degrees. Class 4 are your flammable solids. Division 4.1 are flammable solids, self-reactive substance, and solid desensitized explosives. Division 4.2 are substances liable to spontaneous combustion. And Division 4.3 are substances which in contact with water emit flammable gases. Class 5 are your oxidizing substances and organic peroxides. Division 5.1 being your oxidizing substances and Division 5.2 being your organic peroxides. Class 6 are your toxic substances and infectious substances. 6.1 is toxic substances. 6.2 are your infectious substances. Class 7 are your radioactive materials. There are 3 levels. You have radioactive 1, radioactive 2, and radioactive 3. Class 8 are your corrosive substances. Corrosive substances are substances that will destroy human skin and corrode steel at a rate of 1/4 inch per year. And finally, Class 9 are miscellaneous, which are any material that present a hazard during shipment but does not meet the definition of one of the other previous mentioned classes. First responders, such as law enforcement officers, are classified as awareness level personnel according to the OSHA Hazardous Waste Operations and Emergency Response, or HAZWOPER. First responders at the awareness level are individuals who are likely to witness or discover a hazardous substance release and who have been trained to initiate an emergency response sequence by notifying the proper authorities of the release. The public expects that law enforcement officers recognize hazardous materials and activate the proper local emergency response plan. An incident problem-solving model identified as DECIDE can assist a first responder by detect the presence of hazardous materials, estimate likely harm without intervention, choose response objectives, identify action options, do the best option, and evaluate progress. First responders at the awareness level shall have sufficient training or have had sufficient experience to demonstrate competency in the following areas objectively: an understanding of what hazardous substances are, an understanding of the potential outcomes associated with an emergency created when hazardous substances are present, the ability to recognize the presence of hazardous substances in an emergency, the ability to identify hazardous substances if possible, an understanding of the role of the first responder awareness individual in the employee's emergency response plan, and the ability to realize the need for additional resources. Hazardous materials exist in all types of environments and can pose a substantial risk to citizens, property, and emergency responders. We as first responders must be constantly vigilant in all of our activity, not only while on duty but also off. By recognizing and understanding key clues to a hazardous material situation, we can create life-saving efforts for all involved. Officers should be familiar with the emergency response guidebook before an emergency occurs. First responders must resist the urge to rush into the scene. Approach the incident from upwind, uphill, or upstream, and stay clear of all spills, vapors, fumes, smoke, and potential hazards. It is important that we observe and identify as many clues as possible to the existence of a hazardous material incident. The first responder must also be aware of the totality of the circumstances that created the situation. Be aware of the indicators from your senses of hearing, sight, smell, taste, and touch. These indicators may provide clues, but also indicate a situation that could immediately be dangerous. Odd smells, colored smoke, visible plume, hissing noises from pressure leaks, visible vapor clouds, odd or unusual taste in the mouth, feel of burning or greasiness on the skin. Look for individuals who are lying on the ground and observe the surrounding area for possible clues. Location of the building, such as an industrial site, manufacturer, or shipping terminal, may be an indicator of the incident. Look at container shapes, construction, reinforcement, rings, emergency relief valves, etc. Identify commercial placards, fixed site placards, labels, and container markings. Look for persons exhibiting symptoms of exposure such as coughing, choking, tears, blistering of the skin, redness of the skin, or other unusual behaviors or symptoms. Once the incident is determined to be a possible hazardous material incident, it is critical to gather as much information as possible about the incident to include the identification of the possible material substance based on readily available clues and evidence. Protection of life and safety of emergency personnel and the general public is our first concern. Utilize visible information on packaging such as labels. Utilize visible information from placards, shipping papers, and safety data sheets. Look for physical symptoms experienced by the victims and use the Emergency Response Guidebook, or the ERG. The ERG serves as a guide to assist emergency responders in quickly identifying the specific or generic hazards of materials involved in an emergency incident. It also provides information on protecting the responder and public during the initial phase of the hazardous materials incident. Instructions. The white pages located at the beginning of the ERG include instructions on how to use the book, where to call for emergency assistance, an overview of the hazard classification system, and an explanation of placards and other warning systems. The yellow bordered pages at the beginning of the ERG are your numerical index. They have a numerically sequenced listing of the 4-digit hazardous material identification numbers, followed by a 3-digit emergency response guide number and the name of the material, which we'll discuss a little bit later. The guide numbers refer to the orange bordered pages near the end of the book, which spells out the hazardous encountered in the event of a transportation-related release and the immediate emergency response procedures. The blue bordered pages are similar to the yellow bordered pages, but are alphabetically sequenced by the name of the hazardous material. Response guides are the orange bordered pages, which include the potential hazards to health, the risk of fire or explosion, and emergency response procedures. The green bordered pages identify initial isolation and protective action distances. The final pages are the white pages at the end of the ERG include information on personal protective equipment, fire and spill control, criminal terrorist use of hazardous materials, and a glossary. The Chemical Transportation Emergency Center, or ChemTREC, serves as a 24/7 resource for obtaining immediate critical response information for incidents involving hazardous materials and dangerous goods, and you can find the number for them located inside of your ERG. Using the ERG. Step 1. Identify the material by locating one of the following: the 4-digit ID number on a placard, orange panel, or shipping document, the name of the material on a shipping document, placard, or package. If an ID number on the name of the material is located, find the corresponding placard in front of the ERG and use the referenced response guide number. If there is no identifying information and the material is believed to be hazardous, use ERG Guide 111. If an explosive is suspected but no name or UN number is present, use ERG Guide 112. Step 2. Find the appropriate 3-digit guide number in either the ID number index, which are your yellow bordered pages in the ERG, or the name of the material index, which are your blue bordered pages in the ERG. If the guide number is supplemented with the letter P, it indicates that the material may undergo violent polymerization if subjected to heat or contamination. If the index entry is highlighted and there is no fire, find the ID number and name of the material in the table of initial isolation and protective action distances. Those are your green bordered pages. If necessary, begin protective actions immediately. Step 3 is locate the numbered ERG or orange numbered pages and carefully read both pages. Law enforcement officers can respond to incidents involving the presence of an illicit drug laboratory or the occurrence of suicide utilizing hazardous chemicals. First responders may not realize what they are involved with until they have exposed themselves to harmful chemicals that could lead to serious injury or death. As with any call for service, the worst action is to rush into the situation without a better understanding of what we're dealing with and how we can properly protect ourselves. Clandestine labs, also referred to as homegrown labs, are becoming more prevalent in recent years. Some of these labs pertain specifically to methamphetamine and DMT, ecstasy, and methcathinone. The process of making legal drugs can be fairly simple, and the materials to do so are readily available. Unfortunately, the byproducts produced from these labs can be extremely hazardous to the health and safety of first responders. In 2013, the North Carolina State Bureau of Investigation responded to 561 clandestine drug labs, which was a 22% increase from 2012. 81% of these were simple ammonia one-pot method. This method allows the cook to use a very small quantity of pseudoephedrine and a plastic soda drink bottle to produce the illegal drug. This method is current trend, with over 80% of SBI response being to one-pot labs. The total clandestine lab responses by the SBI have declined over the past 4 years, with 557 labs in 2014, 467 in 15, 376 in 16, and 232 in 17. The trend of reduced lab responses is likely due to the increase in opioid and heroin use, as well as an increase in the availability of quality of methamphetamine ice in North Carolina, which is manufactured in Mexico and then trafficked into the United States. Signs of a potential illicit drug lab. Chemicals and products typically found in meth labs may include, but are not limited to, pseudoephedrine or ephedrine, which is taken from antihistamines such as Sudafed, red phosphorus, iodine crystals, sodium metal or lithium from batteries, anhydrous ammonia, starting fluid, ethyl ether, sulfuric acid from drain opener, hydrochloric acid, sodium hydroxide, salt, lighter fluid, and ammonium nitrate, which can be taken from instant cold packs. In addition to recognizing the different types of chemicals typically found in meth labs, first responders should also be familiar with the types of equipment used in the process. Some of the items include, but are not limited to, condenser tubes, which are used to cool vapors produced during the cooking procedure, filters such as coffee and cloth material, funnels, turkey basters used to separate layers of liquids, gas containers, glassware such as Pyrex, heat sources, grinders, pH papers, which are used to test the pH levels of the reactions, and tubings, which include plastic and/or rubber. Other clues to the presence of meth labs and structures include, but are not limited to, windows covered with plastic or tinfoil, knowledge of renters who pay cash, unusual security systems or devices to include booby traps, increased activity, especially at night, unusual structures, discoloration of structures, a strong odor of solvents, the smell of ammonia, starting fluid, or ether, iodine-stained bathroom or kitchen fixtures, excessive trash. It is estimated that for every pound of meth produced, 6 pounds of hazardous waste is generated. Personal protective equipment, or PPE, should always be utilized when entering or dealing with a potential drug lab. Law enforcement activities may require PPE designed for tactical law enforcement operations. This PPE must be thoroughly evaluated to ensure the appropriateness for the anticipated hazards identified during the risk assessment process. It is imperative that the officer contact the SBI as soon as possible to inform them of the situation. Chemical suicides. A suicide trend that involves mixing household chemicals to produce hydrogen sulfide or hydrogen cyanide, commonly referred to as a detergent. Hydrogen sulfide or chemical suicide is a continuing problem in the United States. The technique began in Japan and has since become the preferred method in other countries, including the United States. During 3 months in 2008, in Japan, 208 persons committed suicide by mixing household chemicals and began breathing it in while in a confined space. Since that event, and with the postings on the internet explaining how to make poisonous gases, these types of suicides have become more common. 7 types of chemicals are commonly used in creating a chemical suicide situation. The following are the most commonly used. Hydrogen sulfide, which is created by mixing toilet bowl cleaner with a sulfur source. Sodium cyanide and potassium cyanide, commonly known as cyanide salts. When it is exposed to the victim's stomach, the salts will produce hydrogen cyanide gas. Hydrogen cyanide, created when hydrochloric acid mixed with compounds containing cyanide. Carbon monoxide, produced by mixing formic acid and sulfuric acid. Also, it is a byproduct of combustion engines and released through the exhaust pipes. Sodium azide, used as a solid chemical at laboratories, hospitals, and farms. It is also found in airbags. The hazardous gas is created when combined with acids, waters, or solid metals. Aluminum phosphide, used as a solid chemical in various pesticides. It will create hazardous phosphine gas when mixed with liquid. Helium and nitrogen, dangerous due to being odorless, tasteless, and colorless. If encountered in concentrated doses, it can displace oxygen and eventually lead to death. During 2011 to 2013, a study was conducted by the National Toxic Substance Incidence Program. 5 of the 9 states participating in the study reported a total of 22 chemical suicides or attempted suicides. There were a total of 43 victims. 15 suicide victims died. 7 victims attempted suicide but survived, and 8 first responders and 4 employees from a coroner's office survived. The remaining 9 victims were members of the general public but also survived. It is imperative that when responding to suspected chemical suicide incidents, emergency responders must take every available precaution to ensure both their safety and the safety of all bystanders in the immediate area. North Carolina incidents. In 2010, North Carolina had 2 suicides to occur in automobiles within less than a month. In Oxford, the deceased victim was in a vehicle. A bucket inside the vehicle contained mixed chemicals that caused acute thiosulfate poisoning. 2 law enforcement officers were exposed, one of whom was treated at the hospital. Local emergency responders evacuated the surrounding homes. The regional response team removed and decontaminated the corpse before transporting it to the medical examiner. In Cary, the victim had placed a sign on the window stating, "Do not open, poison gas." hydrogen sulfide. A hazardous materials response team came from Raleigh to assist and open the vehicle. The emergency workers found the body of a 31-year-old carry man who had mixed some household chemicals with the intention to commit suicide. Signs of potential chemical suicide. Even though most commonplace for these types of suicides is in vehicles, it can occur in any confined space to include bathrooms or closets. Signs, notes, or biohazard symbols placed on windows or doors. Smell of rotten eggs, burnt almonds, or sewer gas, but be aware this may not be any detectable odor. Open pails, buckets, or coolers. Chemical or cleaning detergent containers. Vents, windows, and doors that may have been taped and sealed. Unresponsive subject inside a vehicle, and victim may have seatbelt on to secure the body from falling onto the horn to alert others. Protective measures for chemical suicide. Do not open doors. Do not approach or breathe near the contaminated area. Keep everyone away from the area. Stay upwind of the incident. Contact the fire department and emergency medical services for assistance. Air purifying respirators such as gas masks will usually not protect you from these type of gases and fumes. Keep ignition sources away from the area due to some of these byproducts possibly being flammable. Fentanyl. Over the last several years, communities across the United States have seen a huge increase in the availability and use of dangerous synthetic opioids. The majority of these opioids are derivatives of the synthetic drug fentanyl. Desmethylfentanyl is a chemically modified derivative of the powerful prescription painkiller fentanyl. It is reportedly 40 times more potent than heroin and 100 times stronger than morphine. Furthermore, fentanyl and other synthetic opioids are the most common drug found in drug overdose deaths in the United States. In 2017, 59.8% of opioid-related deaths had involved fentanyl, which is an increase of 14.3% in 2010. Accidental exposure to the first responder can pose a real danger. Fentanyl is designed to be absorbed into the body orally by injection, inhalation, mucous membrane contact, and any transdermal transmission through the skin. Canine officers must be aware that police canines are also at risk. General safety recommendations. If any substance encountered is believed to be fentanyl or fentanyl-related substances, the first responder should not attempt to secure samples or disturb any powdered substance without utilizing the proper PPE. If any fentanyl or synthetic opioid is suspected, the first responder should immediately contact the appropriate personnel in their agency. When encountering unknown powders, the first responder should use PPE that include nitrile gloves, N95 dust mask, eye protection, disposable paper suit, or paper overalls and shoe covers when available. First responders should have naloxone available if exposure occurs. Naloxone is an antidote for opioid overdoses and has a brand name Narcan. Exposure, risk, and treatment. Fentanyl poses a serious threat not only to the responding law enforcement officers, but to all first responders, including medical and fire personnel. It takes 2 to 3 milligrams of fentanyl to induce respiratory depression, arrest, and possibly death. This amount is about the size of 7 individual grams of table salt. Exposure and overdose symptoms include drowsiness, sedation, disorientation, skin rash, clammy skin, pinpoint pupils, and respiratory depression or arrest. These symptoms can occur within minutes. If a possible exposure occurs, immediately seek medical attention. Remove any exposed victim from the contaminated environment to an area of fresh air. If they are exhibiting symptoms of exposure, Narcan should be administered by someone trained in its application. If needed, Narcan doses should be administered every 2 to 3 minutes until the victim can breathe on their own for at least 15 minutes. Anyone who has entered into a known contaminated area or has been exposed to suspected fentanyl-related substances and not wearing a proper PPE should undress and shower as soon as possible while using soap and water. Grossly contaminated clothing should be bagged and destroyed. If the victim has ingested the substance through their mouth or eyes and is conscious, rinse the affected areas with cool water. All skin contact should be washed immediately with soap and water. Do not use any form of hand sanitizer since most contain alcohol. Alcohol will penetrate the skin, thereby possibly increasing the absorption of the substance into the body. So again, your training objectives for hazardous materials in service are to define hazardous materials and the risks associated with them during a hazardous materials incident. 2. Describe the duties of an awareness level first responder at the scene of a hazardous materials incident. 3. List methods used to recognize the presence of a hazardous material to include the identification of the possible material or substance based on readily available clues. 4. Demonstrate the ability to use the DOT Emergency Response Guidebook in identifying a hazardous material and appropriate first responder actions to include notifying additional resources. And 5. Recognize hazards when responding to potential incidents involving illicit drug laboratories and chemical suicides, and how to implement appropriate protective measures. The law enforcement profession requires us to respond and find quick solutions to problems. Often our training involves the use of our equipment and how to address various situations. Unfortunately, hazardous materials can create several issues and obstacles to controlling or resolving an incident, especially due to the threat indicator posed by the material. It is imperative that all emergency responders, especially in the law enforcement community, establish and maintain an awareness of the possible dangers that arise from these situations. We must make proper identification utilizing clues, the Emergency Response Guidebook, and previous subject matter training to quickly contain the incident while quickly working toward a resolution. We live in a society where hazardous materials are often present, either hidden or in plain view. No matter where the material incident is, we must be prepared to safely respond to save lives and prevent further injuries and deaths. To be properly prepared and safe, we must address this training as if our life depends on it. In summary, hazardous materials is a term that often creates fear in many first responders due to the lack of knowledge and facts as well as their confidence in dealing with these type of situations. During this training, we have discussed various types of information that is extremely important to gain a better understanding of the topic. Furthermore, we have discussed methods to improve our recognition and response to these dangerous and unpredictable situations.